Okay, when we talk about a discrete random variable versus a continuous random variable, we've been talking about this discrete random variable in our previous video, and I just want to make sure you understand what is the difference between a discrete random variable and a continuous random variable. A discrete random variable is characterized by gaps or interruption in the values that it can assume. Okay, so for example, the number of daily admissions to the general hospital. We're gonna have 1 admission, 2 admissions, 3 admissions, okay? We could have 5 admissions, so on and so forth. But we're not gonna have like 1.5 admissions into the hospital, okay? The number of decayed, missing, or filled teeth per child in an elementary school, okay? Again, we're gonna count that as the number of decayed or missing. We're not gonna say there's 1.5. If you have some decay, that's a tooth that has decay or that is missing. So 1, 2, 3. Again, it's countable. There's nothing in between. One way, if you're a track runner, that I like to think about it is how many hurdles can you jump over? That is a discrete random variable versus the time it takes you to run the 100-yard dash. The time it takes you to run the 100-yard dash, that is called continuous. It can assume any value within a specified relevant interval of values assumed by the variable. What does that mean? I can run it in 10 seconds, 10.1 seconds, 10.15 seconds, 10.19 seconds, so on and so forth. Between 10 and 11, there is almost infinite number of values that a runner can run the 100-yard dash in between just 10 and 11 seconds or 11 and 12 seconds. Another one is our heights, okay? So again, being relevant, we can have like someone who's 5'7", 5'7.5", 5'7.25". There can be some difference. It's not just a countable thing, right? That's the biggest thing. Discrete is countable. Continuous is not. Discrete, the number of hurdles you can jump over. Continuous, how fast can you run that 100-yard dash? That's the difference there, okay? If you have any questions, let me know. Let's go to a discrete random variable here. At a carnival game of chances involves spinning a wheel that is divided into 60 equal sectors. The sectors are marked as follows. $20 is 1 sector, $10 is 2 sectors, $5 is 3 sectors. No prize is 54 sectors. The carnival owner wants to know the average expected payout for this game and the amount of variability as measured by standard deviation associated with this. We don't have to, we have to write our own probability distribution. We don't have a probability distribution, so we need to do that now. How do I do that? Well, let's talk about what our X is. Look at the question to help you. We want to know what the expected payout is. Okay, that's how much are we going to win? Okay. And then we're going to look at the probability of that happening. Well, the first thing that we could win is $20. What's the probability of that happening? Well, there's 1 sector out of a total of 54 sectors, 57, 58, 59, and 60 total sectors. So 1 of the 60 sectors has the $20 on it that we could win. There's a 1 in 60th chance that we could win $20. $10. There are 2 sectors with $10. So there's a 2 in 60th chance of winning $10. $5. There's a 3 out of 60 chance. I feel weird saying 60th. That's weird to me. And then finally, no prize. $0 for our winnings. There's a 54 out of 60 chance of that happening. Now let's say the average expected payout. That is the expected value, okay? So what we're going to do, we're going to show our work, or we're going to take that observation, and I'm going to type it because it will go a little bit faster. That observation times the probability of that observation. Oh. Plus the next observation times the probability of that observation, plus the next observation, times the probability of that observation. Now, if you're watching this video and you're like, what is she doing? That means you did not watch the video that I posted before this on how to find the expected value. That's where I go into in depth on how do we get this, okay? I'm going to make this smaller so it looks better. But really, expected value, you get your formula on the formula sheet. I showed you where to find that. And it's just taking each observation, okay, and multiplying it by the probability of that observation. Now, I am not going to find the standard deviation for that one. And the reason I'm not going to find the standard deviation, because I've already shown you how to find the standard deviation in the other video, and I just don't want to waste the time. The main thing I wanted to get from this video is that you understand the difference between a discrete and a random variable. And then, okay, right, that's the first thing. And then the second thing is, how do I find an expected value when they don't give you that probability distribution? You have to actually figure out that probability distribution. So that was the purpose of this video. I'm not going to go to example 3 right now because that's going to get into my next video. So thanks guys for watching. Write down any questions you have. Let me know during class. Thanks.